All right, hello and welcome everyone to this webinar on the topic of OAuth, OpenID Connect, and Open Policy Agent used together to achieve fine-grained authorization. We are two speakers today, myself, Jonas Igman, and Anders from Styra. Why don't we start with introductions here? Anders, I'll let you introduce yourself.
Yeah, sure. I'm Anders. I work at Styra, and I've previously worked at Curity, so I'm pretty familiar with both of these technologies. So yeah, I've been working in with identity access control and so for the last 5 or 6 years.
Cool. And I'm Jonas Igman. I work at Curity. I have not worked at Styra, but just like Anders, I'm originally from Sweden, but I currently live in the US. Been at Curity for over a year, but involved in identity and access management for probably about a decade in different types of forms. So let's go through some quick sort of housekeeping items. Everyone that's on the webinar is centrally muted. There's a place within the webinar to submit questions, so please do as we go along. We'll keep an eye on it and might answer some questions as we go along, but probably for the most part, save the questions for the end. The webinar is recorded, and everyone that's registered will receive a link with the recording after the webinar. So let's look at the agenda here and what we're going to talk about. I'll start a little bit with covering the authorization server. This is the OAuth and OpenID Connect server, and look at different tokens, access tokens, and scopes and claims predominantly, since that's sort of a pretty good or important component in how both Curity and Open Policy Agent can interact and integrate. Anders will talk a little bit more about the Open Policy Agent and policies and how that's modeled and how OPA can consume an access token and these scopes and claims that Curity can provide. And intertwining all of this will obviously be some demo aspects as well. We'll try to demo most of the topics that we're talking about here. So, starting with the Curity Identity Server, it's a very powerful identity server. It has a lot of different capabilities. Obviously, I've sort of pinpointed a couple of things here that are more relevant to this topic that we're talking about, which starts with the user authentication. So the Curity Identity Server includes an authentication service where user authentication is handled, obviously. Within that, there could also live an optional authentication workflow. There's a lot of powers within the product. The Curity Identity Server has capabilities to bolt on an authentication or a workflow in the authentication process where we can handle a lot of different things. I'll cover that a little bit more as well. But after the user authentication, the token service takes over, and this is where tokens are issued. We will look and talk a little bit about the different types of tokens, but importantly, as I mentioned before, in that process is the scopes and claims that we will be able to sort of hand over or send as part of a request to Open Policy Agent for consumption. And this is parts of what Anders will show in his demo as well and talk more in detail about. If we look at the authentication service itself, there's a lot of capabilities in here, but obviously it handles user authentication. Within the Curity Identity Server, it comes with lots of already available authentication methods. So this could be, your traditional username, password authentication, but it could also involve social authentication like Facebook, Google, etc. There's a lot of them already in the product, but Curity also provides several of them as open source on GitHub, so they can actually be, tweaked and customized to your own liking. It's also possible to develop your own authenticators using the plugin SDK that Curity offers. Within the authentication flow there, you can add on what we call authentication actions. This is something that can be triggered in this process to, for example, look for geolocation use cases where we can detect where the login is happening and take action on that, for example. They could also be things like date and time related actions. It can be used to look up additional details, information about the user from various data sources. This can also be used for linking accounts. If you have social accounts that would be linked to internal accounts and things like that. So there's a lot of power in the authentication flow there. The authentication can also handle, in a lot of cases at least, account registration, password reset, or if you forgot your password or forgot the account and things like that. Single sign-on is enabled by default and also handled here. We can put in pretty advanced use cases for multi-factor authentication. You can chain these authenticators. So I could have a username password authenticator first that then triggers an SMS or email authenticator or something else. We can also handle step-up authentication. So they could be scenarios where you try to access a resource that requires a more robust authentication, and based on the specific resource, we trigger a multi-factor, whereas other resources of lower importance does not require multi-factor authentication, for example. When we start looking at the next step, we have authenticated the user. This is obviously an important aspect for performing fine-grained authorization that OPA will be doing. There's not a lot of policies. There's obviously policies, but it's more interesting fine-grained authorization use cases, I would say, if you know who the user is, right? If you don't know who the user is, yeah, then you can talk server to server or service to service authorization. But when it comes to anything involving a user, you have to know who the user is, obviously. So the authentication service there is crucial from that perspective. Once we know who the user is, Curity's token service takes over, and this is where we can issue tokens. This is also extremely flexible and configurable. We won't cover all of that in this, but we have in general two types of tokens that are used. There could be additional ones too, but opaque tokens, or what's also referred to as by reference tokens, will look like a GUID, basically, like in this example here in the deck. That's a token that can be passed around, but it doesn't hold any visible information to anyone. What you need to do with a by reference token is essentially introspect the token to get more information on it. The other alternative, which we'll probably use, or which we will use more here today and also in the demos, and we'll look at that, is JSON Web Tokens, or JWTs. This is instead of by value token. So this is a token that holds values instead of just having a reference to the information. It's holding JSON data. It could be encrypted and or signed. And we'll look at that. I think Anders will actually consume a token and validate the token. So it will be a signed token that will be validated and dereferenced, basically decoded, so that we can read the information in it. This is a JSON Web Token. This is a JWT. This information is obviously doesn't mean anything to the naked eye, so to speak, you can't really read this, but the parts in the JSON web token here is 3. We can see that in the color coding, but the green part is the header of the JOT that contains information, and one of the more important aspects in there is it contains the algorithm used to generate the signature. And the signature of the JOT is the yellow part. The pink part is essentially the payload. It's the data that we're, for the most part, interested in. And that pink part looks like this. This is sort of the JOT payload or body that is decoded from that previous one. It's been reduced a little bit because it actually, in my case, contained a lot more, but I kind of cherry picked some of the claims that are in here, and this is where we're going now, right? We're going to scopes and claims next. So a JOT contains claims. In this case, we have, for example, the scope, but we also have the issuer, the subject, which in this case is Alice. We can have other bits and pieces in here. There's claims there for records, read and write, for example. And so the scopes here is the important, or not important necessarily, but the interesting part. Scopes and the claims, in this case, it would be probably the records. We're going to see some similar data to this in the demo later. So what is a scope? A scope is essentially, in this simplistic sort of explanation of it, it's a group of claims. It is defining the access requested by the client, and here it's a scope equal records. That we'll see it a little bit more in the demo, but that denotes that we can, in the request from the client, we can request a set of scopes, and in this case, that is the scope records. Since a scope is a group of claims, if we're allowed, based on configuration and whatnot, we can get a set of claims that groups to that scope. The important part here too is that we can trigger consent by the user for the scope. So you're essentially consenting the use of a given scope as a user, and you can, depending on configuration, you can also deny the consent, obviously, which means that the access token wouldn't be issued with those claims. A scope can be used for authorization too. We won't really go into that today because we're talking about fine-grained authorization essentially. But a scope could be used for a level of coarse-grained access in, for example, a gateway, where you're sort of earlier in the stage of fetching or receiving or resolving data, meaning that it's probably cheaper to do some kind of access control in that stage. So yeah, coarse-grained access in the gateway, and if that goes through in an API gateway, we can sort of move onward in the architecture, and that's where we get to OPA, for example, that will then consume sort of the claims. A claim is attributes that are asserted by some trusted party. This trusted party, in our case here, is the issuer, and you can see that earlier in the decoded JOT that there was an ISS or an issuer claim. That's denoting the trusted party who asserted the claims that are in that token. So the attributes here tell us information about the user or the subject, but it's, as we could see in the decoded JOT, there's also additional claims within a token that could be used. And I think, Anders, you'll be using some of that in the demo as well, because you can use the issuer claim, for example, but there's also other pieces that could be used within that. That's not necessarily directly related to the user, but you have things like expiration within the claims as well. So in essence, the claims are attributes, and what OPA is doing is a level of attribute-based access control. It's using attributes to apply to a policy to form an authorization decision, right? And so claims and attributes are synonymous there, essentially. Some of the pieces that the Curity token service is doing, it's performing that scopes to claims mapping. So I'm requesting a scope. What claims will that result in? That's something that the token service will handle. It will map the information from authentication to claims. This is part of the authentication step, potentially. It doesn't have to be, but it could be. And it's fairly common that it is. So what I mean by that is there's a lot of attributes that could come from the authentication step, from the authenticator itself, but also from that authentication workflow that I mentioned and the authentication actions. That could result in data attributes that are resolved from different data sources. And the token service is responsible for mapping those attributes and that information into claims that are then issued in the token. Claims to token mapping means that we can control which type of tokens the different claims go to. There are different types of tokens: access tokens, refresh tokens, and ID tokens, depending on your depending on the flows that we execute. But it's possible to control which tokens the claims gets mapped to as well. And this is important from a perspective of sort of PII information. You typically want the access token to be sort of consumed and used by maybe the client application. But depending on the application, you don't necessarily want an ID token in that, because an ID token can contain PII information, for example. So you might have regulatory compliance issues and things like that. So it's important to sort of control which claims go where and what tokens end up where in your entire architecture. There are some possibilities there within the token service and conjunction and coupled with an API gateway that you can look at next that can resolve some of that. Again, filter claims to release to the client, and this is essentially consent, right? We can actually filter claims based on user consent. We don't want to release claims that are not consented by the user, right? So that's one aspect that the token service handles as well. Filter claims to release to the client is we can configure different clients, different OAuth clients within the token service, and this will then make sure that only certain claims goes to the correct requesting client. In some level of an architecture here, we can see that in the top left, we have a client requesting a token from Curity. The token can get passed to what's listed as a PEP here. It can essentially be an API gateway. The API gateway could optionally, it's not listed in here, have an arrow back to Curity where we can have the gateway introspect the token or do things like what we call the phantom token approach or the split token approach, so that the gateway itself can actually get hold of the user information or the ID token that then gets passed after that. I'm going to go into that in detail, but we have some good articles on that as well. I'm going to do a quick demo to show how we get a token and how that could look like in Curity before Anders can demo his part as well. So I'm going to use OAuth tools for this demo. It's a pretty powerful and useful tool for testing OAuth and OpenID Connect flows. What I have here is this. So this is operating as an OAuth OpenID client, essentially. This is talking to my Curity server, which I also have in here. I have a client that's called OPA demo. These are the scopes that I'm requesting. So I'm requesting an OpenID scope and the record scope. The OpenID scope is a standard scope, which will result in me getting an ID token. So we have something to look at there. I'm forcing login here, just so we can see that the login is actually running. In the end, what happens with all of this configured is that we're executing this that's down here. So when I click run here, I get a login screen. For demo purposes, I have a pretty simple login. This could be templatized, configured, and to look exactly the way you want it with a username and password authenticator that this is. When I log in here, the result is 3 tokens. I get an access token, a refresh token, and an ID token thanks to the OpenID scope there. If we look at this part here is obviously the JOT, right, that we looked at before. It's color coded differently, but it's the same. This here is the decoded JOT. So here we can see the header. We can see what I mentioned before. This is the algorithm used for the hashing. Here's the payload, and then it has validated the signature down here. In the payload, we can see 2 pieces that are configured here that are interesting. The records scope is actually giving me the subscription level claim here and the company ID claim. This part is configured. This mapping is configured in Curity. So if I would not request a records claim, I wouldn't record scope, I wouldn't get these 2 claims here. Within Curity, these are also actually resolved from a database that has the information of the mapping of subscription level to the user in this case, for example. And so this is the information that can then be consumed by the open policy agent within the policy and perform authorization on these. All right. Anders, you want to take over from here, because this is sort of the moving point over to OPA, because now we have the pretension is here that we have a token now, right? Now we are passing this token in some way to OPA, and that's what Anders is going to show us what OPA can do with it. Yeah.
Yeah. All right. Let's see here. Okay. So can you see my screen?
Yep. We see it.
Okay, great. Yeah. So before we pick up that token and do something useful, I figure we would need to at least have a quick look at what OPA actually is and why it's so useful. So first off, I think I already did the introductions, so I'll just skip on them. But so what's the purpose of OPA, or what problem are we solving? And the real problem we're solving, I think, the main problem we're solving is that the modern tech stack increasingly looks something like this. And this is obviously not even listing all the technologies out there. This could almost be a single company just with a bigger enterprise. So we have all these different application and programming frameworks. We have deployment platforms. We have these cloud environments, and we have all these diverse data sources. And they can all have their own way of managing policy. And authorization is obviously one, maybe the most prominent type of policy. But they all have their own way of managing, who can access Postgres, or who can access your AWS account. And there's really no, even though they're all doing the same thing, there's really no similarity in how you do that or the format of that. So that's the challenge. It's to manage this, manage these policies across this pretty increasingly diverse and heterogeneous stack. So the goal of OPA, or Open Policy Agent, is to unify this, and that's what OPA really is. OPA is an open source general purpose policy engine. It offers a unified toolset and a framework for policy across the stack. It decouples policy from application logic. So that's kind of the main point of OPA, that you can extract policy from these very local, very specific areas, and you extract it, and you kind of so you can reason about it, and you can work with that in isolation. What OPA does is this kind of policy decision. It's a decision engine. It doesn't do the actual enforcement. So whether you choose to act on some alert, or somebody who is not allowed to do something, like whether you send back a HTTP status code, or whether you send a message to some Slack channel, that's the actual enforcement. And OPA doesn't deal with that, but OPA will tell you or try and give you a decision so that you can, based on those facts, that you can enforce that decision. And OPA policies, they're written in a declarative language. It's called Riga. We're gonna look into that in a bit. And since OPA is general purpose, and it truly is general purpose, the use cases are ranging from such a kind of wide topics like Kubernetes, admission control, where you decide what gets to be deployed or not in your cluster. Microservice or app authorization, which is, of course, the topic of today. Infrastructure as code, like these kind of policies, whether you can order new VMs or compute instances, etc. Filtering data sources, build pipeline policies, whether you can deploy on Saturdays or Sundays, so there's a whole a wide array of use cases.
One of the strikes me as one of the powerful things there is the decoupling of the policies from applications itself, right?
Yeah.
And the fact that it's sort of centralized and standardized across all those applications that you decouple it from, which gives sort of a pretty powerful aspect of auditing. You don't have to audit every single application with its own individual proprietary format of some kind of access policy, right? You have one standardized format for policies across a bunch of different applications and architectures.
Yeah, certainly. So that's definitely a good point to drive home. Like, when was the last time somebody checked like the access logs for, I don't know, Apache Kafka? Like, nobody ever does that. And if you have these, and also all these logs, they're also going to be in their own like home cooked format.
Yeah.
So there's really no like unification in those either. So what you really need to learn is like you need to learn some specific DSL for doing like policy and authorization. You're going to have to learn their log format and so on. So even though there's certainly OPA is something new and it's something you need to learn, I think like it will start to pay off pretty quickly. All right, OPA is an open source project. It has a vibrant community, but it's not just an open source project. It's also in use by some of the biggest companies in the world. So how does it work then? We call this a policy decision model. So OPA, pretty much regardless of where you kind of put OPA, it's going to work something like this. You're going to have your service, and with service, this could be a microservice, this could be an API gateway, or this could be a database, or even like a PAM module. So your service is going to receive a request of some kind. So a user is going to ask to, I don't know, access a Kafka topic or to access an endpoint in your microservice. So that's the incoming request. And your service, in turn, is going to turn to OPA, and it's going to ask, is this something we can allow? And OPA, based on the policies you provided OPA and data that could either be provided as part of the request or that you might have stored beforehand, can then make it an informed decision, and it will send that policy decision back to your service, where then the service will do the actual enforcement. So the service might respond with like a 403, or it might do some form of logging or so. So that's kind of the basic model of the policy decision model. And of course, this scales so well because what this policy request is just a JSON body, and the decision is also just a JSON response. So anything that talks HTTP and understands JSON, which is pretty much all software written the last 20 years or so, can interact with OPA, and that's why it has seen so many use cases. So as for deployment, OPA is a single tiny little binary, so you can run it pretty much anywhere, and it doesn't cost a whole lot. It's pretty lightweight, so rather than have like these big fat instances where you put it, you much often, or you rather see like people deploying hundreds or thousands of OPAs. So the idea is that you want your OPAs as close to your service as possible. Of course, the purpose of that is these arrows. So you want the latency between the service and OPA to be as low as possible. So normally you'd actually deploy OPA to the same host, your local host. So then you'll see like a latency cost of maybe 2 milliseconds, and that's often considered fine. But there are also some other like more esoteric ways of working with OPA. If you have a Go application, you can import OPA as a library. For Envoy and Istio-based like service mesh applications, you can use a specific plugin for OPA. And there's also a WebAssembly component to OPA, so you can compile your policies into WebAssembly. Okay, so if we kind of zoom out here, we saw this before, the policy decision model. If we zoom out to like the Curity context or the OAuth microservice architecture, you'll see here a pretty good representation of how an architecture like this would work. So you kind of deploy your OPAs inside each of your service. It's an HTTP server, so it's just running as close to your service as possible. You don't really, it's not like you import OPA as a library in most cases, but it's going to run just next to your services. And like the identity part, of course, that's what security handles. So the user or the client, the cell phone, the robot, or whatever it might be, it goes there for authentication and gets handed this token in return. And that's then what's getting passed around in the cluster. And that's used as an input for OPA to make this decision. So that's part of the data. Again, it's all just JSON. So obviously you can just, you can fit a dot into that query and have that as part of the decision. And all these OPAs, ideally, they talk to a bundle server or some centralized component like a management plane. That's one of the parts that Styra provides. But this could also be like Amazon S3 or something more simple, where we push all our bundle or policies here, our data, and then each of our OPAs can go and just fetch them. And they will also like check periodically. So if there's a policy update, they're all gonna go there and fetch that. So policies are decoupled also in that form that they have their own like deployment lifecycle. You don't need to redeploy all of your apps just because you add a row or something like that. And as Jonas was talking about there before, there's also decision logging built into OPA. So any decisions taken in any of these systems is logged, and it's sent back to this central location where you can kind of have all the decisions ever made by OPA in one place. And of course, once you've done this for your microservice environment, there's really no reason to stop there. But once you're familiar, one of the big benefits of having this unified way of working with policies is then you can pull in Kubernetes, then you can pull in Docker, pull in Terraform, pull in anything, because any of these technologies, they're all JSON or they're all YAML. So that's exactly what OPA is talking. So any declarative way of dealing with data is a good fit for OPA. Okay, so that was kind of the high level architecture. So what about policies themselves and policy offering? So policies, again, they're written in a high level policy language, which is Rego, of course. And a policy works like this. It's a number of rules. And these rules can return pretty much anything. They can return anything that's valid JSON, pretty much. You'll often see for authorization, you'll often see like true or false. Are you allowed or not? No, you're not, or you are. That's kind of a binary response. But it could be like, you might also want to know why are you not allowed. So you might want to include a string, or maybe have a more rich object in the response. And that's all supported in OPA. And there's a whole bunch of built-in functions that you can use for dealing with JSON Web Tokens, date and time, math, and so on. Of course, in the demo in a bit, we're going to be looking at using JSON Web Token and the built-ins around that. And there's also a unit test framework. There's great docs, and there's a playground. So that's kind of covers the policy part, at least before we take a deep dive into that. But before we do that, should just mention there's also another component of this is data, because we can have as many policies as we want, but unless we have some data to deal with, it's not going to do a whole lot of good. So data, again, we can either provide it as part of the input. When we ask a question, we can also say, here's the user. The username is this. Or we can have OPA, or we can push in all that data into OPA beforehand, or we can have OPA go and fetch that periodically through the bundle API. As a last option, we can even, at policy evaluation time, we can have OPA go and actually call remote endpoints to fetch data. Okay, so that's a little demo. That's demo time. And before we kind of pick up the JOT here, or the JSON Web Token, I'm thinking like maybe we should just take a very, very quick look at Rego. So for those of you who are entirely unfamiliar with that. So again, the way we work here is we have a package, that's our policy. And the policy consists of a number of rules. And the rule looks something like this. It has a name and it has a body. And if all the statements or expressions here are true, then we say the rule is true. So we can see if we query OPA for this rule here, we're going to see that, yes, it's true, because the assertion in here is true. If we add more, they all have to be true. So if we do that, it should still be true. And if we say something silly like this, we'll see that it's no longer true. It actually disappeared, because one characteristic of Rego is that anything that isn't true is undefined. So if we want to change that and we want to respond with something like false, we can say that by default, allow should be false, which is a pretty good default. Okay, so that's just silly data. We might want to say here, we might want to use something as part of the input. So this is kind of what we'd send from this request. We'd send something like this into OPA. We'd probably send the path of the request. This could be /user /username or something like that. And we probably want to know what the user is trying to do. Are they trying to read that? Are they trying to push or put, or post or put? And who is this user? So we might want to say, we might, for example, say that if the input path is equal to users, and the input method is equal to get. So again, if both of these or all of these are true, then we say that the rule is going to be true. So we can see that now the allow rule is true. And if we try and do something else here, we're trying to create a new user, we see that we're not allowed to do that because these statements here are no longer fulfilled. So that's kind of very, very basic, the very basics of how policy evaluation and kind of REGO works. One thing to note, though, is we might, of course, want to add more conditions that would make this true. So we say now that anyone can read, that's fine. But what about if we want some users to be able to edit maybe their own user, but not anybody else's? We could add another allow rule. And we could say that if the input path is equal, or we say, let's start with the method. So if the method is put, meaning if someone is trying to modify a user, then we're going to require that the next part of the path is equal to the name of the user. So basically, you're trying to edit your own user. So we're saying, like, if the input path is equal to users, and the next part is equal to the input user name, then we are going to allow that, because you can edit your own user. We can see here that if we change the name up here, so the user Anders is trying to edit put on his own endpoint. We can see that he is allowed to do that, but Jane can, on the other hand, not edit the Anders user. Or sorry, Anders cannot edit the Jane user. So that's a very basic policy evaluation, and in just 13 lines of code, you can still express quite a lot with these kind of primitives. And just to go a bit more advanced here, or a lot more advanced, I'm just gonna we're gonna check these JSON Web Token that Jonas left us. So the input here, as you can see here, we kind of skipped on the user, and because but why would we have that when we have a token? So we have a JSON Web Token, and that would contain all the data we need. And we can see here also that we have a data contained in an external data source, or from external data. And in this case, it's the JSON Web Key set, which we can use to verify this token. And we can see here we have 3 conditions that would make allow true, or 3 rules for that would make this allowed. And all of them requires that there are valid claims that this rule is true. So we might want to check that first. And the way it works here, we then see that we have another rule, or another object referenced here, which is the claims. And then we have these kind of attributes on the claim that all need to be true. But before we check that, we might want to check, like, where does this claim come from? That comes from another rule, where we use one of these built-in methods to verify the token. In this case, it's an RSA token, and we kind of after we have verified the token, we can then go ahead and decode it. So we kind of extract the payload out of that. And this means that the return value of this rule should be that payload. So that's how we get the claims, and we can just evaluate those if we want to check the token. And this is not really the token I got from Jonas. It's a bit of a simplification, but some of the parts are in here. Like, we can see that the issuer is there, and that we obviously want to verify that. So this token is issued by a trusted party. We can see that the audience is verified, and we can see that the expiry is verified as well. Obviously, in a real case, you'd probably want to add much more to this verification, but it's a very simple way of doing it. And we can also see here that in this case, the token contains some roles, which we map into a set. Set is a very nice data type to work with in REGO, and for things like roles, it's pretty much always what you want, because there's always going to be the roles are always going to be unique. You can't really have 2 roles or the same role multiple times. And order is not important. So for policies, you pretty much always want to work with sets. Unfortunately, there's no representation of a set in JSON, so we need to convert that, and that's what we do here. And if we go back up to these allow rules, we can see that as long as the claims are valid, which meaning like if these assertions are true, and the roles or the role here, if the role contains admin, the admin role, and we can see here that it doesn't. Oh, sorry, it doesn't. So this is not going to be true, but this would be a pretty common rule to have. Like the admin can do anything. You can see here we only check for that role. There's no other checks, except for we still require the token to be valid, but we don't check for the endpoint or we don't check for the operation. So the admin can do anything. As for the other users here, we see that the records reader group or the role is allowed if the first path component is records and the method is get. So they can read, which kind of makes sense from that role. And correspondingly, the records writers are allowed to write to the records endpoint. So yeah, there's some more complexity added, but still, this is pretty much it for verifying a token and using the claims as part of our policy. So that was very basic policy dealing with OAuth, dealing with JSON Web Tokens as part of the input. So so where do you get started? If you think like this sounds like a good idea, I'd suggest you start small. So like just maybe play around some in the playground like we just did. It's a very good learning ground. And then the OPA docs again, they are fantastic. I think it's probably one of the better documented open source projects out there. And then maybe start to look at applications close to you. Maybe a microservice, maybe some app you built before or a library, and then kind of start to identify which policies you might have in there, because you can't really choose whether to work with policy or not. You always have policy of some type. It's whether you choose to acknowledge and kind of deal with that separately, or if it's still like coupled to your application. So once you identified policy, then you can start to delegate. So start small again. Just maybe take a single endpoint, maybe take a single role. Let the admin role go through OPA and have OPA decide on what that can do or not. And then you kind of expand from there. And once you have a couple of OPA running, then you scale up. Like start to look into these management features of OPA, like the decision logging, bundle servers. How do you provision policy across like hundreds of applications or services? And as a good learning resource, there's the Styra Academy, which is like videos, tutorials, and quizzes, so on. So I can heartily recommend that. And of course, there's the OPA Slack. There's almost 4,000 members, I think, currently. So do join us there. And with that, I say thank you.
Nice. Yeah, I think there's actually more than 4,000 on that Slack channel. I'm on it as well. It's a good resource for sure. All right. So we got a couple of questions submitted here. So I think we'll spend a couple of minutes checking those out and answering. First one, in situations where a user can have a huge amount of roles, and maybe it would be difficult to include all of them in a token, is there any recommendation from an OPA point of view?
Yeah, sure. There's a few ways of doing that. And one way is to kind of preload all the roles into each OPA. So you'd pretty much just take the subject or the username or the user ID, and then you do a lookup in like OPA's memory, what roles are associated with that user. Of course, you lose some of the benefits of letting your like identity system deal with that. But there are also some other like benefits of doing it. So it depends on the use case. Because one problem with like JSON Web Tokens is of course that they are immutable. So should it be that like some role or some user did something very stupid, so they're like fired on the spot, and then you'd want to revoke their admin rights, but their JSON Web Token is not it's not gonna it's not gonna help you in that, because it's gonna say for the duration of its lifetime that this user is an admin. So in those cases, you might even want to employ some like combination. You check, you have like a block list, which you check for each request, and then you use that in combination with data provided in the JOT.
Right, and that's where it's sort of expiration of the token and think like how long a token is valid for and things like that would play in, which is also heavily dependent on the use case and what you're dealing with and what type of environments you're operating in and things like that, right?
Yeah.
So I guess that also kind of answered the next question is, can OPA get input data from other sources besides the incoming request, which is yeah. The short answer is yeah, but I think you also kind of mentioned that a little bit, right?
Yeah, so you can either push data into OPA, or you can have OPA periodically go to some remote endpoint to fetch policies, but it can also fetch data. So,
right.
So depends a bit on like your tolerance there for like,
Right.
yeah, how stale can this data possibly be?
Right.
Is 5 seconds okay, or is it going to have to be like on the same second? Because if it's like that, you might need to actually go to the data source for each request. But ideally, we'd avoid that, because that model doesn't scale very well. If all your microservices have to go to some remote data source for each incoming request, it's going to be
right. I've noticed before when looking at it too that I actually didn't notice it in your example there, but it's possible also to get sort of the public keys for verifying the signature of the token. That's possible to do sort of an external call out to the identity provider, right? And get it, as long as the identity provider exposes that, which it should, but that's also possible. But then you would get into that too. Do you want the microservices to do that on a regular basis? But from what I can understand, OPA says the possibility of potentially caching that public key, right? So you don't have to make a call out every time you get a token to verify it. You actually can have the public key to verify the signature cached within the OPA itself. Yeah.
Yeah. No, that's very common to do, like for that scenario where you have like a JOX endpoint. And right. It doesn't change frequently. It might change like a couple of times a day due to some like rotation. But so you could cache that result for an hour or until you have like an invalid JOT coming in, and then you kind of go and fetch a new one.
Right. How does Curity get claim values? So I didn't actually show that too much, but Curity has connections to essentially any underlying data source, but it could get claim values from the authentication step in itself. If you perform authentication against, let's say, GitHub, for example, you use the GitHub authenticator, you get a whole bunch of attributes back in that process. That could be a claim value, but you can also then within the authentication flow there look up attributes or data from underlying data sources. Could be any type of database or REST JSON service or LDAP or you name it. You can custom write your own connectors to whatever data source you want. Next one's for you, Anders. What's the output from this OPA tool? I'm assuming this is maybe referring to the playground. I don't know. Is it a DLL or what is the actual thing which will be deployed with the service using the OPA?
Right. So OPA is a standalone binary. So you don't link to OPA, or you don't. So you run OPA as a little small little binary, and it runs its own web server. So the way you query OPA from your app is through the REST API OPA exposes.
Right.
So OPA is written in Go, so it runs on any platform, any kind of deployment target.
Not exactly the same, but related. How can Curity be deployed? Valid question. And I think you mentioned sort of talked a little bit about how OPA is deployed there and architecturally. But so Curity can pretty much be deployed anywhere. On-prem, you can deploy it to any cloud. If you look at the Curity resource section of the Curity website, you will find how-tos on sort of getting it deployed on different platforms. We provide Helm charts, an official Docker container, obviously. What else? CloudFormation templates, Azure templates, and AWS AMI. It's super flexible in how you can deploy it and get it up and running.
Yeah, so I saw there are some questions on the regular chat as well.
Yeah, there's one here on OPA pricing.
Yeah, it's like they say, if you have to ask, you can't afford it. No, it's an open source project, so it doesn't cost anything to run. And for most deployments, if you just want to try it out and run it, and you can scale up pretty big deployment scenarios without having to pay, and you don't really need to pay anything for even if you go above that. But you might see the need for to centrally manage like policies, to kind of know what's going on in all your OPAs and so on. And that's what Styra, the company I work for, provides. But there's no cost in running OPA. That's and there's never going to be one. It's an open source project. There's like 200 contributors from so many companies. So we are pretty much just one of the maintainers, or the big maintainer, but we're far from the only one.
Cool. And you can couple that with Curity's community edition, which is also free. So you can sort of two components that you can essentially set up what we looked at here without much effort and much cost too. I think we have maybe one last question. Are there any sample PEP, i.e. policy enforcement point, that call OPA, or do we need to write our own?
Is there any sample PEP policy?
Essentially, is there any sort of ready?
Right.
I think the question is there any ready-made components that would make sort of the authorization call to OPA, like a plugin for an API gateway or
all right. Yeah. If you go to the OPA website, there's a link called ecosystem, and if you click that, there you'll see I think there's over 50 ready-made integrations already for integrating OPA in like Python, Node, Java, .NET, pretty much any language or framework you can think of. So.
Cool. So it's pretty much sort of plug and play in a way, but you gotta obviously make sure that the correct data that you want to send in is there, but it's establishing the connection and doing sort of all the framework around it. Yeah.
Yeah. Cool.
All right, I think that's the last one we have time for. Thanks everyone for joining and listening. We'll send out a link on the recording of this. Obviously, you have the OPA Slack channel. I'm not going to front Anders's email address, but you can reach Curity at info@curity.io, or you go to our website, curity.io. Lots of information and details there.
You can definitely, if you have questions later, you can just send them to Anders at styra.com.
Same goes for Jonas at